All right, welcome back. This is section 6.5, Trapezoidal Approximations. And what we're going to do is instead of rectangles, we're going to go ahead and make trapezoids. It's a bit more complicated, but it's more accurate. And so our goal is going to be to say, well, okay, how could we simplify this more complicated strategy? So let's take a look at a quick graph. And we'll see if we can simplify this. So I've got some function, and it doesn't really matter what it was. So we'll just do something like that. And we'll say that this is A right here, and we'll say that this is B right here. We're looking for the area under this curve. So I'm going to call A x sub 0, and I'm going to split this into a variety of trapezoids. So we'll call this x1, we'll call this x2. We've got x3 right here, and if we keep going, what we end up with is that this is x sub n. Since we started with 0, 1, 2, 3, 4, this will be n. And this is x sub n minus 1. Now, additionally, we have a width h of each. And here's what we know. If I make these into trapezoids, I can calculate the area of the trapezoids using my trapezoid area formula. Area of a trapezoid is equal to the sum of the bases over 2 times the height of the trapezoid. So let's write this out. The integral from a to b of this function f of x dx with respect to x can be approximated by, well, I've got h times y sub 0 plus y sub 1 over 2. There's trapezoid number 1 plus h times y sub 2 plus y sub 1 divided by 2. There's my second trapezoid. And so on, plus dot, 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 all the way up to h times y sub n minus 1 plus y sub n divided by 2. And that's my last trapezoid. And the plus dot, 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 of course, is all the trapezoids in between. Okay, so what can we do to simplify? Well, thing one, I'm going to factor out h. Thing two, I'm going to factor out the 2, the divided by 2. And what I've got here is y0 plus y1. That's the first trapezoid, plus y1 plus y2, plus dot, 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 plus y sub n minus 1 plus y sub n minus 1 plus y sub n. First trapezoid, second trapezoid, last trapezoid, and a little bit of the previous trapezoid to illustrate something that I'm about to show you, which is that there are 2 of each of them with the exception of the starting point and the ending point. So if we want to approximate using trapezoids, we can say that the integral from a to b of f of x dx is equal to the height over 2 times my starting y value plus 2 times each of my intermediate y values plus 1 of my final y value. 2 of each and only 1. And it turns out, we could do a little bit of fiddling around, but this is the average of LRAM, the left rectangular, and RRAM, the right rectangular. LRAM is going to start with y sub 0, and it's only going to go to y sub n minus 1. RRAM is going to start at y sub 1, and it's going to go all the way to y sub n, which means I've got 2 of each of the things in the middle, plus the LRAM endpoint, the RRAM endpoint, divided all by 2. We get that average. So a couple things we do need to think about here. One is that h must be constant. In other words, all of my trapezoids must be the same width. And we know that it's equal to b minus a divided by the number of trapezoids that I choose to have. And we call this T the trapezoidal approximation. And it's h over 2 times, as I wrote above, y sub 0 plus 2y sub 1 plus dot, 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 plus 2y sub n minus 1 plus y sub n. That is the trapezoidal approximation, and it can also be found by averaging the left and right rectangular approximations. So that's the basics. I'll come back with a second video where I'll do 2 examples. Pretty short section, pretty straightforward. Cannot emphasize enough what do you need to remember, that the intervals must be constant for this to work. And I'll show you, well, I probably won't show you, but the time when you would find intervals that weren't constant might be when you had a data set, and so you collected your data at uneven intervals. All right, thanks for watching. We'll see you next time.